This is part 2 of logarithmic questions. Till question number 18 we have done in part 1. Now let's see this question. Log of 9, log of 9, log of 9. Okay. All bases same. Perfect. Now here I cannot write it like this: x plus 6 minus x is equal to 2. That is not correct. Why? Because if we need to equate the log values, they should be like this: some value over here and some value over here. Base is same, so I can equate these values. But here it's not the case. Here there are two logs, this log on the left hand side. So first let's see what we can do. Yes, we can apply log of 9 of m minus log of 9 of n is equal to log of 9 of m upon n. Because maybe there is no base, okay, but if there is any base, it should be same. Here base is 9. So I can write it as log of 9 of x plus 6 by x is equal to log of 9 of 2. Now I have one log with base 9 here and one log for base 9 here. That means these values have to be same. Only then these two logs can be equal. Perfect. So now it's simple equation which we have to solve. Multiply by x on both sides. Right. So x and x cancelled, and x plus 6 is equal to 2x. Subtracting x on both sides. So this is cancelled and 2x minus x is equal to 6. So if x is equal to 6, then these two values are going to be equal. See, there can be many situations. For example, in question number 18, log of 12, some value is equal to log of 12, another value, and this is possible only if two values are equal. So if we equate it here directly. But in this question, we have log of m minus log of n. So you have to apply the property first. Okay. Now let's see another question where definitely the base is same. Let's see the question carefully first. Log of 4 of x plus log of 4 of x minus 12 is equal to 3. Now definitely I know that if it is log of a of b is equal to, say, x. So in exponential form, base x, this power is equal to b. I can convert that. But here it's not possible because here we have log m plus log of n. So it's not possible here. So first we have to solve this log of m plus log of n, and log of m plus log of n is equal to log of m times n. Right? And that is equal to 3. Now we are at a stage where we can convert log into exponents. So this base 4, this power cube is equal to x minus 12. Now this is a simple quadratic equation. So let's solve this. 64 is equal to x minus 12. Now I can just reverse the sides, and when I reverse both the sides, no sign changes. See here, just see the difference. I have only make left hand side as right hand side or right hand side as left hand side. Nothing other else has been changed. So apply distributive property, this and this. X squared minus 12x minus 64, that is equal to 0. Subtracting 64. Okay, let's not do two steps together. This is equal to 64. Now subtracting 64 on both sides, because I need to make equation is equal to 0 to solve it. Minus 64 is equal to 0. This is cancelled. Now because this is a quadratic equation and we have to find two factors of it, so we are going to apply the AC method. See, whatever you have learned before is going to be useful here. So this b value, it comes here, and this negative 64, the constant one, that comes here. Now you have to find two values which gives negative 64 when we multiply or negative 12 when we add or subtract. So it's plus 4 and negative 4 minus 16. It is giving me negative 12, and 1 multiplied, it gives me 64. So I can break this into x plus 4, the first number, and x minus 16 as the second number. Now here we have applied AC method. Here we will apply the zero property, that if product of the two factors is 0, then one of them has to be 0. So either x plus 4 is equal to 0 or x minus 6 is equal to 0. Subtracting negative 4 on both sides, x is equal to negative 4, and here this is sign for or. This or this is equal to plus 16. So x is equal to 16. Now if we see, we have calculated two values of x. Perfect. But here we are not solving quadratic equation. Here we are solving logs, and this quadratic equation is a result of a logarithmic equation. So we have to go back to our question and check which value gives us the positive this. So if I put negative, what is our value? Yes, negative 4. So this x negative 4 is not possible because this value has to be greater than 0, right? So that means we have to ignore negative 4 even though it is a result of a quadratic equation. So x is equal to 16 is our solution. So be careful, you are not solving quadratic equations and these two values are results of the quadratic equation. Go back to the question and check, are these values satisfying the log rules? If not, ignore that particular value. So here we are ignoring negative 4. Okay, let's experience one more question. This is question number 21st. Now no base, right? Log of 5x minus 12 is equal to 2, right? No base. So just remember, if you are doing math questions and there is no base, that means it has a base 10. So I can write it as 10. Now why I have to think this? Because one side we have log and another side we have value, right? So this is like a hint that okay, it has to be converted into an exponent thing when one side is a single log and another side is a value. So immediately the property which strikes us is that we can convert it into exponents. So 10 squared is equal to 5x minus 12, right? So 5x minus, I'm just changing the two sides, 10 squared, 5x minus 2 is equal to 100. Adding 2 on both sides, it's cancelled. 5 of x is equal to 102. Dividing by 5 on both sides. Okay, it's like kind of a mixed fraction, but that's okay. This is the value which is going to satisfy our log. See, so it's a different question. No base was given, but we know if no base is given, we have to put log 10. And why that is necessary? Because I have log only on one side, not on the other side. So I cannot equate 5x minus 12 is equal to 2. So I first convert it into exponent first. You can take it as a type, right? If there is a single log and a value, you have to convert it into exponents. Okay, let's see question number 22. So similarly here, as it was log 10, now I'm writing natural log of 4x minus 1 is equal to 3. Again, here it is log, here it is value. So I cannot solve this, right? So the simple basic thought is that I have to convert into exponent, but there is no base. So we know natural log is actually log of base e. 4 of x minus 1 is equal to 3. Now you can convert it into exponent. Okay, one more thing. Just remember, like e is a constant. Yes, it has, it is like decimal value, too many values, but it is a constant, right? So if you are solving this question, use the calculator and find the value of e cube. Okay, let's first change the sides. So e cube is basically 20.08. I'm using the calculator. Okay, 20.085537. Adding 1 on both sides, it's cancelled, is equal to, if you are adding 1 to it, right, so it's like 1 this. So 1 will be below 0 of 20. So it is 21.085537. Now dividing by x, 4 on both sides. See, because it's not a value which is ended here, we have rounded it off, right? If you use the calculator, you will see that I have rounded it off. So I will not say x is equal to 5.271384. No, I'll say x is equivalent to this value. That means we have rounded it off. Okay, one more type of question. So we have done almost all questions of equations where you have to find the value of x. Now I am going to take questions of a particular property which we learned as like log of, suppose this base has some power and this value again has some power. They are different, right? And remember, it's not whole. This n power is with b only. So that is equal to n over m. This value over this value is equal to log of a to the power b. Now this property is much more useful. For example, when you have like log of a to the power m and somehow you are able to convert this as again 2 and then it is power n. So now this is n over n log of a to the base a. Now if you go to the second part where I have explained the base values, you will see log of a and is 1. So that is n upon m. This is really helpful. Like you will say, okay, why cannot I use, like my question is, okay, let's solve a question. This is question number 23. Now you will say my question is like log of 4 times 64. Okay, let's apply base rule. Log of 64 by log of 4. Use the calculator and we are done, right? So what's the need of learning this rule? See, when sometimes calculator is not allowed, in fact, if we know this property, we will solve it faster than the calculation, because this is the power which is the answer if we get the base and the value same. Let's see some of the question. Okay, that is not question number 3. I have to solve it. So I can write it as log of 4 is 2 squared. And what is power 64? 64 is, I can write 64 as 4 cubed, right? So no need to write 2 square because 64 itself can get base as 4. So that is 4 cubed. Now this power is 1 and this power is 3. So this is 3 log of 4 of 4 and log of 4 of 4 is 1. So our answer is easy. This property is that useful. Now let's see it in a little bit of tricky question, like question number 24. It's log of 5 root 5 and let's say here it is 5. Now, first idea is that these two are not same. But what if I go to the very basic rule of exponents, like I can write it as 5 times 5 to the power 1 by 2. Square root is power 1 by 2. So when bases are same and multiplied, powers are added. Right? So powers are added, that means I have to write the base ones. Here it is 5 to the power 1 and 5 to the power 1 by 2. So I have to write the base 1 and it is 5 to the power 3 by 2. How I have added? 1 plus 1 by 2, half, 1 and a half, right? 1 and a half. Or if you want to apply the butterfly method, it's like multiplying these two and multiplying these two and then the denominators. So 2 plus 1 by 2 times 1 is 2, 3 by 2. That is the butterfly method. So that means I can write it as log of 5 of 3 by 2, this power, 5 of 1. Now both the bases and the values are same. So I can write it as 1 over 3 by 2 log of 5 to the power 5, which is 1. So it is equal to 1 over 3 by 2. Now if you go to the rules of fractions, the denominator part is reciprocated. So it is 1 times 2 by 3, which is 2 by 3. See, we can use this property so beautifully. Okay, now let's do question number, why I always forget the question number. Question number 25. I think I'm most concentrated on the questions, that is the reason. Okay, let's do log of 6, 216 root 6. Now calculator is not allowed. I have 6 over here. So let's see, can I convert 216 into 6 to some power? So 216 is actually 6 cubed. And this root 6 is 6 to the power 1 by 3. So again, I have to apply the same rule as I did in the previous one. So it's 6 to the power 3 plus 1 by 2. Now I have to solve these fractions. So 3 is 3 by 1. Butterfly method, this is multiplied by this. This is multiplied by this. Whatever the sign is, put it over here. And denominators are multiplied. So is equal to 6 raised to power 7 by 2. Now it is log to the power 6, 6 to the power 7 by 2. So this power is 1, this power is 7 by 2. So that is equal to log of 6 of 6, which is 7 by 2. Okay, now again, let's use this property, or let's see a different question. It's log of k to the power a times log of 5 to the power k is equal to 3. Now if you go to the base rule videos, you will find out that we created a pattern there, right? And that pattern will help us to solve it in a single step. K is present as a base, as well as, you have to find a, that is our question, as well as its value, right? So that means whenever you have some number or a constant as base as well as value, it get cancelled out, and whatever is left, 5 as base and a as value. So that is the pattern, and this is equal to 3. Now you don't want to learn the patterns, yeah? That's your wish, you don't want to learn it. So let's do it with proper base rule. Log of k of a, you can write it as log of a by log of k times log of 5 of k. You can write it as, by applying the base rule, log of 5 cancelled, and this is equal to 3. Now it's log of a over log of 5 is equal to 3. So isn't it opposite of the base rule? So you can write it as log of 5 of a is equal to 3. Just see what your style is, how you are comfortable with. Either solve every part, or if you love to follow the patterns, just do it like this. Now it is pretty simple. I have to convert it into exponents. So 5 times 5 times a is 125. So it's just like a wonderful question. Okay, now let's see one question with fraction where we are going to apply like again the basic rule of exponents. So let's say question number 27 is log of 4 of, now it is 1 by 2, right? I can see 4 is 2 squared. I can see 2 is power 1, but it's 2 and it's 1 over 2. So then again I have to go to very basic properties of exponents, that if we change the numerator or the denominator, power changes. If no power is given to you, that means it has power 1, right? So it will be 2 to the power negative 1. Problem solved. If we see another example, for example, if I have, okay, let I have 2 squared, right? And I just want to reciprocate it. So sign of the power will change. Suppose if I have negative 2 to the power 2, this negative is not the sign of the power, right? So here it will be as it is. Only sign of the power changes. So if we come back here, I can write it as 2 squared and this as 2 to the power negative 1. We are done, right? So it's negative 1 over 2 log of 2 of 2. Log of 2 of 2 is 1, and so negative 1 by 2 is my answer. See, it's not always that you are going to get the same base and the value. Question can be different. Let's say it is log of 27 and it's 1 over 4. It can be like this, right? Let's solve this. Let's make it another question. So it is 3 3s are 9 3s are 27, and 1 over 4 is actually 1 over 4 is actually 1 over 2 squared. So I have to make it 2 to the power negative 2. Now they are not same, right? But even then this property is applicable. Negative 2, this power here 3, and you are left with log of 3 of 2. So if it is not the same, maybe this will be one of the options. And if calculator is allowed to you, it can be negative 2 by 3 log of 2 by log of 3. You can just calculate this value and write your answer, right? We have done 28 questions, no doubt, but I think we have covered all the part. So just revise this and send me the doubts in the comments. I'll send you those questions, right? Okay, I think we have done almost every type of questions. Just try to follow the pattern. Good. Okay.